The Columbia Water Center is working in Brazil with funding from the PepsiCo Foundation to provide access to safe water and to improve the efficiency of water use. In this video, we'll look at the Water Allocation Project located in the capital city of Fortaleza in the state of Ceará, Brazil, which uses an innovative climate prediction model to help local people distribute water more efficiently. By constitutional law, decisions about water use in Brazil are made not by a central authority, but by local water allocation committees, made up of residents and representatives of different sectors which use water, like industry and agriculture. COGER, the State Water Resources Development Company, oversees the supply infrastructure, the dams, reservoirs, and delivery system, and makes short-term supply predictions. But the water allocation committees decide who is going to get how much water each year. Urban consumers have first priority, then agriculture and industry. Since they can't foresee how much rain there will be in the future, the committees tend to release water from the reservoirs very conservatively, so they can be sure there will be enough for next year. When less water is released than would have been possible, there isn't enough to go around and the economy suffers from lost production. The Columbia Water Center's Allocation Project incorporates advanced climate science for the prediction of local rainfall into the water allocation process, giving the committees better information so that the resource can be used more effectively, increasing economic activity and incomes.
The climate information comes to help us to make a better assessment of the risk of the next year. And the better assessment of the risk of the next year could provide us one tool to use more water this year. And use more water this year improve the system because we can allocate more water. Allocate more water is more water to produce some benefit for the society.
If we think only about the water we have to distribute along 6 months, it's simple. But when you think in a longer period, like 2 years, 3 years after that moment, things start to be complicated because of the climate. Because we have to be very careful about how much we can distribute if next year will be a dry year.
The project includes rainfall projection taking into account climate change, a sociological study of the human factors in the allocation and supply system, training of state water infrastructure technicians, training of water allocation committee members, and work with state and federal agencies to expand the use of the methodology. Let's begin with the rainfall prediction science.
You see, some year the flow is high. The other year the flow is not so high. The other year is this high. The other is not so high. Then you have some variability. Then you have the strong seasonality and strong variability between years. Okay, and we construct this reservoir to reduce the variability of the yield. Then this reservoir, what's the basic idea that we have is get this water from this year to this year with low water. And we can use the climate information to analyze what's happened here in the second year. And perhaps is zero, or close zero, perhaps you have some flood, or perhaps some point here. Then we developed one methodology to, from July of this year, make some inference to what's happened in July, December, July. Then now we can estimate some probability of each one of the scenario. Using this probability of the scenario, we can analyze, for example, if you need to keep, we can analyze if it's necessary to keep this amount of the water or reduce this amount of the water. If we reduce this amount of the water, we have more water available this year to supply the irrigation industry and urban. Okay, then if you have more water to use on this and you allocate more water on this, you increase the production here because they don't have a shortfall.
The information actually given to the allocation committees is much simpler.
is like this. If you use 10 cubic meters per second, the probability of you have a shortfall in the system is 10%. If you use 7 cubic meters per second, the probability is 2%. If you use 20 cubic meters per second and take from this reservoir, your probability to shortfall is 30%, what they want to select.
And then it's up to them to decide how much risk they're willing to take.
Yes. Because today they don't know the risk. Each one of the system, they have their own information. They don't get for the other. They have their own information for that system. Mm-hmm. This is what we need. And to do this, we need to do some hydrological studies, because in some place they don't have flows, and you can use some models to estimate the flows. And we need to get more information about the reservoirs in the region, mm-hmm. and we need to know exactly the demand they have in the field, and we need to estimate the loss they have in the river using the monitoring of COGER. Mm-hmm. And then it's a lot of work, because each one is specific.
Utilização desses modelos, o aprimoramento vai permitir com que a gente possa, com o aumento do conhecimento das variações do clima, essa metodologia permitiu uma previsão, uma utilização, um planejamento mais para longo prazo. Muito bem.
Programa mais aplicado à evolução científica aqui dentro, nós nos tornamos mais eficientes, visto que você vai ter mais respostas, mais cenários, né? Você vai ter mais, vamos dizer assim, aplicabilidade, né? Ter mais opções, porque gerenciamento de recursos hídricos são opções, você tem muitas opções de como fazer. O programa dá cenários que você vai poder melhor escolher a forma melhor e mais eficiente de gerenciar os recursos hídricos. Eu acho que o programa em si ele vem dar esse benefício, né?
But the best science in the world won't help if it can't be used by the people participating in the water allocation process, or if the process itself doesn't work well. That's where the sociological study comes in.
Then Christine works on this, because we need to analyze how the people represent the system, how the aversion of the risk, what kind of the understanding that people have, and how they can use the information to change the power equilibrium in the system.
So I started to do interviews with some stakeholders in the 3 levels: state, national, and municipal. So now I can work on a local team and try to understand how are they involved or not, valid or not this process, this model.
You're the one you need to say, to understand a little bit more how we can, what kind of the image or picture or shape the data and the information need to have to more easily to be understood by the people. How? Because the people now, they understand the impact of the numbers in their daily life. They know, for example, if you talk about 10 cubic meters, what this means in the level of the river. If they talk about the reduction of the reservoir from this 20 centimeters, what this is representing the reduction of the area for the crop or something like this. They have this information. It's unbelievable, but they know exactly. They have a good map from the numbers of the simulation to the reality. Then the main question is, we don't want to lose this learning. Okay? Then we need only to improve this process. Then
that for me more impressed the change of language. The local people can understand the energy engineers and the political technicians speak. So they start to understand hydrological data and something like that. And I said, wow, that's amazing. because that's really difficult. The language, that's for me, that's wonderful, a big success. We can start to make a language that they can comprehend and understand each other. That's, for me, that's a great thing. That's the most impressive.